All right, I was muted for a second there. Here we are. This is the notes for section 2.5. This is the second section of applications. This is applications involving percents. So we did consecutive integers, we did translating word problems. This is just a step further to things that involve percents. This is mostly shopping math. This is math you do, right? So the first set of questions is about tax rate, computing sales tax. So you're buying a digital camera, it costs $429.95. Compute the sales tax if the tax rate is 4%. Determine the total cost if the including tax. So there's actually two questions in here. So be careful when you see this in ALEKS, they're asking for two different numbers. Compute the sales tax if the tax rate is 4%. Remember that 4% as a decimal is 0.04. 0.4 is 40%, right? So to find the tax rate, all we're going to do is multiply. This is when having your handy dandy calculator is handy dandy. 420, oh, sorry, too many decimals, 429.95 times 0.04. You do that math, you get the amount of tax. That's 1720. You're calculating that in your calculator, please, right? And then really to get the total cost, all we're doing is adding 429.95 plus the tax. You know how to find the cost of things, you shop. So in total, the camera with tax will be $447.15. Ta-da. All right, you do the same thing for this second part. So assume the tax rate is 6%, find the total cost including tax. Now this one only has one question in it, right? It doesn't say compute the sales tax first. So you actually have two choices. You can do this in one step or two. I'm going to show you the way we just did this here is two steps. You're finding the tax rate and then you're finding the total cost. You can also find just the total cost with the tax rate, okay? If this confuses you, just ignore it. But for some of you, it will work better. So the idea here is that when I pay for something and tax, what I'm paying for is 100% of the cost of the thing, right? Plus whatever the sales tax is. Does that make sense? So actually, instead of multiplying $89 times just the 6%, which would be 0.06, what I can do is multiply it by 1.06, 106%. And that's going to get me the total. So this is just sales tax. This is going to be the total plus sales tax. Okay, so if I did 89 times 1.06, I would get 94.34. If you're just doing the tax, do just the tax percent. If you're doing the total, it's 100% and that tax rate. If I did the same thing up here earlier, I would have done 429.95 times 1.04. That would have gotten me 447.15 right away. Either way you want to approach this is fine. I don't have a judgment on it. I want you to do the way that makes sense for you to calculate it. So pick the way and use it, okay? All right, an unknown percent. So 240 college men were asked what intramural sports they enjoyed playing. The results are in the graph. What percent of men preferred tennis? Well, how do you figure that out? For the most part, the easiest way I know to set up things like this is with a proportion. So proportions are part, whole, equals part over whole. It's just two equivalent ratios. So in this case, I can think about percents. I'm missing the percent that preferred tennis. That's a part. But a whole in a percent is 100%, right? The other ratio is that part of the men like tennis, 30 of them, out of 240. So I have two equivalent ratios as a proportion. What the heck do you do with it now? Do you remember how to solve a proportion? When we have two equivalent ratios like this, we cross multiply across the equal sign. So I'm going to get x times 240 equals 30 times 100. 240x equals 3,000. Divide by 240. X is 12 and a half. It's 12.5%. Okay, so when you do that actual calculation, you do 3,000 divided by, 240. You get the percent as the answer. Okay, it's already in percent form, so you don't need to move the decimal. All right, what percent of men preferred basketball as their favorite sport? Well, do the same kind of calculation. The other thing that you can do, the other way you can think about this, is to think about it as just the part in the whole of the men surveyed. So if you go back, 90 men liked basketball out of 240. And if you just make that division, 90, so pick up your calculator, divide 90 by 240, you get 0.375. Okay, in this case, this is the decimal version of the percent. This is just 37.5%. So 37.5% of the men preferred basketball. All right, let's try something different. Andrea spends 20% of her monthly paycheck on rent each month. If her rent is $950, what's her paycheck? For this, we're going to go back to that part whole thinking. Okay, so we have part of the percent. We know 20% out of 100%. And then we have to think about the rent. Rent is part of what she pays, right? It's part of what she pays out of her total paycheck. So it's really rent out of her check. So the way I'm going to write that is 20 over 100 equals 950 over, I don't know how much she makes, but it's got to be more than that. She's got to be doing okay if her rent is $950 a month, right? So cross multiply across, so 20 times x equals 950 times 100, that's 950, 0, and divide by 20. X is, I don't know, I didn't actually write down the answer. 9500 divided, 9500 divided by 20. She makes $4,750 a month. Good for her. I like it. Okay. Same thinking here. You try this one. In order to pass an exam, a student must score 70% of the questions correctly. If there are 42 answers, if 42 questions correct gets a 70, how many questions are on the test? So think about part and whole. 70% is the part of the grade you have to get. And in order to get that, you have to answer 42 questions right out of however the heck many there are. You do the math to solve this. When you do, x should be equal to 60. There were 60 questions on the test. All right. We have two more kinds of things. Okay. One of the other applications of percents is simple interest. It's when you start to buy things like cars and houses, not so much houses, but cars, the rest. Investing in banks, where we have to start talking about interest. When we borrow money, it's compound interest, but when they give us money, it's simple interest. So the formula for simple interest is one you need to remember. It's one of the 2 or 3 in this whole course, but you do need it. So the formula for simple interest is that the total amount is P plus PRT. So P is principal, the amount of money to start with. R is the rate. T is the time. Okay. little t. Big T is the total. Sometimes they make that A too, like the amount. My brain broke a little there. So Jorge wants to save money to buy a car in 5 years. He needs to have $20,250 at the end of 5 years. It's very specific. How much does he need to invest in a CD at 2.5% interest rate? When you do these, you're going to write the interest rate as a percent, as a decimal. Okay, so we need to convert that. So we know some things. We know the total is going to be 20,250. Oh, it's a terrible looking comma. My apologies. We know the amount of time is 5 years. We know the rate as a decimal is going to be 0.012. Oh, no, 0.25. Sorry, I got an extra one in there. And the thing we don't know is the principal. That's X. So we're going to fill in what we have. 20250 equals X plus X times 0.025 times 5. Okay, you can do this. So 20250 equals what's 0.025 times 5 is just 1, or it's 0.12125. Okay, so I get X plus 0.125X. That's really just 1X and then some more, 1.125X, and divide by 1.125. And when we do that division, we get X is $18,000. So if he invests $18,000 now, he can just let it sit there, and in 5 years, he'll have enough for the car. I don't know if that's the most effective way for him to save his money, but you know, is what it is. You try the next one. Think about it the same way. It says Cassandra invested some money in her bank account, and after 10 years at 4% simple interest, it grew to $7,700. What did she start with? Okay, so I know the rate is going to be 0.04. I know the time, little t, is going to be 10. I know the total is 7700. What I don't know is the principal. That's going to be X. This one sets up the exact same way the last one did. So try it out. I will tell you the amount she invested initially was $5,500. If you get stuck, come on into the discussion. You know what to do, okay? Ask, let's work it through. All right, this is the last count, kind. Sorry, I think I've been recording a lot of these in a row. My voice is starting to get a little scratchy. So after a 38% discount, a used treadmill costs $868 on eBay. What was the original cost of the treadmill? Okay, so we're gonna write a verbal model first. Yeah, come with me here. So the idea is that the cost, right, minus the discount is whatever the price is. This is a sale price. True? Cost minus the discount is the sale price. Agreed? Okay, well, I don't know the cost. This is X. The discount is 38% of X. It's 38% off the original cost, right? So it's like a tax. I would multiply that amount by X. So I'm going to write 38% as a decimal, 0.38 times X. 38% of X is the amount I'm getting off. And that total equals the sale price, 868 That's the cost of the treadmill. So remember that this is a 1x, okay? So 1x minus 0.38x would get me 0.62x. That equals 868. Well, now I only have one step left. I divide by 0.62. X is, what is it, $1,400. Now here's the thing, does that, take a pause for a second, does that make sense? Well, the original cost was definitely more than the discount, so that makes sense. It was not quite half off, and half of $1,400 would be $700, so actually that does make sense. You can sit and make sense of this. You try the second one, okay? An iPod is on sale for $151.20. After a 20% discount, what was the original cost? Set it up the same way you did this one. Please, please, please. Try it. I will tell you when you get to the end that the original cost of the iPod should be $189. If you get stuck, ask for help. You know how to do that. Awesome. I'll see you in the next section.